Everybody, welcome back. So something that I've been asked a couple of times and wanted to do a little bit of a project about is how to kind of turn a visual effect into an installation, and ways that you can kind of think about building a system to cross that Rubicon. From I have this cool effect to here's a way that I can present the cool effect in installation for people to come and experience. So to that end, we're going to be looking at using a virtual canvas to display multiple effects for a installation that we'll be designing. And part one of that is going to be creating perfect mosaic tiles so that we can turn any rendered top into a nicely tiled grid that we can then do a bunch of stuff with. So to shed a little bit of light on kind of where we're going with this, we're looking right now at the finished product. As I did with the last tutorial that I released, this one is going to be released kind of with the entire end project file from the beginning, and I will be building up to it over the course of a couple of videos. But this way you guys will have the entire thing at the beginning and can follow along. So if you want to do that, you can head over to my Patreon and grab the project file there. If not, we will be rebuilding the entire project from scratch, so you don't need to subscribe to Patreon if you don't want to. But if you do want the project file, that's where you can grab it. So, again, what we're looking at is kind of the end result. So we have one specific visual effect right now. We can see that there's a little bit of framing, some rendering in post, and then this kind of main effect. So while it may look like this is something that you could just do super easy with some comping, we actually have something pretty cool going on. So this canvas is actually being comprised of an array of instanced quads. And these quads are then being textured using just little slices of our input texture. And this then results in us having these nice little tiles that are also instances, so we can treat them very similar to a particle system, or how we would treat any other instance network. I think this is important, or at least interesting, because it is not the same thing as doing, let's say, an array of instanced quads and then just looking up the color of each quad from some image. Right? That results in some sort of pixelized effect. But what we're doing here is actually looking at the texture and dividing it up based on the number of tiles we have. This lets us do some other cool stuff. Like, for example, here I'm adding some optical flow perturbation. So, I'm just using click and drag with some optical flow adding to my velocity map. But this is already something that would be much more difficult to accomplish without using kind of this technique. And something else that we could look at is one of the things that I really like, and that is being able to transition between one effect and another effect based on different materials and some very cool kind of advanced render functionality, which we'll be looking at once we get to that point. So, like I said, it's kind of cool because we can have all of these different installation scenes, if you will, and then we can have all of those scenes kind of piped through this virtual canvas. And the virtual canvas can add another layer of interactivity or design to your effect or anything. So right now, I'm mostly going to be showing you kind of how to build a system that is going to function in this way. And then we can talk about some ways to kind of start using this from an artistic perspective, because I do think there are many very interesting avenues to explore here once you start getting into things. for example, instead of just having kind of, transition, okay, now we have our next effect. One thing that we are going to look at later on is going to be actually tying that transition somehow to the effects so that our canvas and the scenes themselves are kind of inextricably linked in a very cool way, in my opinion. So, there you have it. That is pretty much where we're going to be going with this set of tutorials. So I'm going to pause there and basically from here on out going to be rebuilding this entire thing from scratch. So like I said, if you haven't grabbed that project file to follow along, this will probably be a pretty good time to do so. And I guess my last note there would be I am using the fluid simulation that I share with my Patreons. You don't need to use this fluid simulation for this effect. We will very easily be able to just use noise or whatever else you like. So this is optional, but by no means required. So, with that said, let's jump into things and start rebuilding this. So I'm just going to save this as a new file, and I'll call it live. And then I think that what I will do is basically just delete all of this stuff. So now I have nothing but my out, and from here we can really get going. So the first thing that I want to do is lay down just the overall structure of our project, because, like I said, this really is meant to be a installation, and that installation is going to have multiple generative effects. So I'm going to call those scenes, maybe, and then we're going to have another section. It's going to be our virtual canvas. And then we're going to have a final base here. This base is going to be our post-processing. Now, we might have also an input. And so that will probably come back to. I'm actually going to ignore it for now, but just so you know that we might have one of those, or you can add one if you like. So in scenes, I'm going to simply drop down a noise for scene 1, and we will translate this a little bit. And then I'll copy and paste this. I'll make it not monochrome, and I'll change the seed. And then we'll just do this. And all I'm doing here is just changing the period of these two noises a little bit, and the translation speed. And so then we can basically have our two very simple effects, out 1 and out 2. Each of these would probably be something like this in our real installation. So we'll call this scene 1 and scene 2. So like I said, these can be anything. And right now they're just going to be these noise fields. This toolbar is the function store toolbar for TouchDesigner. There's just an article that TouchDesigner released that talks about where you can get it and how to use it. But you can also just head over to @FunctionStore on Instagram and grab it from him. Dan is super talented and a great developer. So these buttons are pretty helpful for workflow. I definitely recommend checking it out if you are interested. So, okay, now I've got my my scenes here. And so the first thing I'm going to do is just get an in and an out. And then I'm going to do the same for my post. Just do an in and an out. And now I have a chain that's linked the whole way. Okay, so now that we have our scene set up, which again can be anything, I'm just using this noise for now. The next thing that we really need to do is talk about our rendering as well as our virtual canvas. So we'll jump into the virtual canvas and we'll start to set some things up. So the first thing that I'm going to do is just drop down a geo. That's just a placeholder. We're going to come back and get rid of that later. So we'll then just add a camera and a light. And then we'll just constrain the light to the camera so that it is wherever our camera is at. We'll wire this render into our out, and we will make sure that our render resolution there is properly set. Although I think that what I probably want to do... Oh yeah, okay, so that's all good. Okay, so here is kind of where we're going to start. This obviously doesn't have anything to do with our effects yet. So what we need to do is set up a little network that'll let us get our effects ready. So I'm going to put another geo down actually, and I'm going to call this tiled grid geo. Now, what I'm going to do is start making, building out my network inside of this tiled grid geo. So I'll add an in, and we'll go up a level. I'll drag this in one in here. We'll call it in base color. Use Alt-N to add a null. Delete the torus that was here and replace it with a rectangle. Now the rectangle will make size 0.1, and we will first just drop a null down. Then we'll use a constant material, and we will again drop a null down, and we'll call that null matte. Now I'll call this null base, and then we have our parent components, or sorry, our parent parameters. We can do a couple things. We can turn on instancing. We'll get back to that. We can use period/matte as our reference to this material operator that's inside our parent. We can then drop our color map on the constant. And from here, we can see that we do have a rendered quad that has our palette as the render. That's easy. Everybody knows how to do that. Before we go any further, I'm just going to use a select, and I'm going to select the out1 component, or sorry, the out1 operator from above. And that's just so that we can see what we're working on here while we're working. Okay, so the next thing that we need to do is get our instancing. So let's first think about a kind of what we mean when we talk about this tile grid. What we really mean is if, oops, okay, maybe this is better. Grid, we'll turn on instancing already, so we can just do this. And don't worry too much about what's happening right here. I am just making a point. So here we can kind of see what's happening, or we can start to think about what we mean. So when we have this virtual canvas and we want it comprised of little tiles, we want really two things. We want to have a grid that has points that are spaced appropriately for our aspect ratio and the number of grid tiles that we want to have. And we want to have the texture on each of those tiles appropriately mapped so that it looks up just that slice from the overall palette. Right now you can see that our entire background is just being stretched over all these tiles, which is fine, but not like really what we're looking for. So what we're going to need to build is a little instancing pipeline, and that instancing pipeline is going to give us tile positions. It will calculate the number of the tiles that we need, and it will also scale those tiles both in XY space as well as their texture coordinates to allow us to have then an aspect corrected grid that is fully filling up our render viewer and has perfectly mapped texture tiles. So we can start by getting rid of this grid. We could use a grid for what we're trying to do, but I prefer to use GLSL because it is more lightweight and allows us to do a lot more configurability. So I'm going to do something that I'm sure you guys have seen me do before, and that is use vuv.st to just set up a little UV baseline for my GLSL. Now, we need to know the resolution because this is going to be used for instancing, so the resolution of our texture should be the same as the resolution that we are looking for. So let's create that resolution on our parent parameters. Right-clicking this icon is equivalent to doing a right-click and customizing parent component. I'll create a new name, page rather, called params. And to that page, I will add a grid res XY parameter. I'm going to add another parameter, and that's going to be target grid res. And this is going to be an integer. Now, this will make go from 0 to 100, and we'll default it at 50. Then I'm going to drag and drop that grid here. So we're dragging and dropping our target grid res on our grid res x parameter. Then we're going to add another parameter called aspect ratio. This will be, or rather just aspect. This will be a float, and we will use our virtual canvas. Well, I guess what I'll do is add a resolution parameter to my virtual canvas, and I'll associate that resolution parameter with my project resolution. And now I can give my virtual canvas component a parent shortcut. Maybe I'll call it canvas. And then my my grid aspect, I can use the shortcut parent.canvas.par.output resolution y divided by parent.grid.output resolution x, which didn't quite work. It was resolution 1, not output resolution. Okay, so now I have an aspect ratio here. And sometimes what I like to do then is make my aspect ratio read only so that it's just more evident that it's like special. So now we can finish this grid resolution calculation off by referencing grid res x in our y, and then just multiplying it by our new aspect parameter. So now we have this slider that'll let us change the grid resolution, and then we will always have an aspect corrected grid because we just take this as our x and then calculate our y. The last thing we want to do is because we can't have a quarter of a grid tile, we want to just make this an integer, and I actually want to make it rounded up, so we can use math.seal, and then we have still optimized expressions, and we have a nice dynamically calculated grid resolution and a slider for us. So now I'll take that grid resolution and I will drag and drop it on my UV and set it to 32-bit float. From here, I'm going to drop down another GLSL. And in here, let's see. And in here, this is going to be our initial calculation. So what we're going to be doing is scaling UV to world space. Well, it's really just scaling UV to world space. So we need a couple of vectors. This can go over here for now, whatever. So we'll need a couple of vectors for us to be able to do this. One will be EU res, and we'll make that this grid res. I'll actually make it U grid res. We will then want our aspect ratio, so we can grab our aspect ratio, and then U bounds. Now, let's get rid of all of this and take a step back again. So what we're really looking for when we say bounds is what are the world bounds that our render viewer is going to be capturing when we are rendering this final scene. So this is basically a number that we can just select. It doesn't have to be anything specific. But it will be something that we use as a basis for a lot of our calculations. So it's just good to know that this is one of the parameters in this that will be pretty manual in the sense that when you adjust it, there might be some manual adjustments you make elsewhere in the network. You'll see what I mean in a second. So I'm going to add a parameter to my virtual canvas. I'm going to call it xbounds. Not a folder, a float. And I'm going to make it 100. And I'm going to give it a default value of 100 as well. I'm going to customize my grid component, and I'm going to give it an xbounds parameter that is also a float. And then we will drag and drop our parent on top of it. The reason I'm doing that is because we might want multiple grids in our installation that don't have the same xbounds. For example, I once did a installation at a museum that had one big grid for the background and then like 10 tiny little grids that were all used independently, but each of them were kind of basically just like copy and pasted, just with different bounds. So, all right, now we have our bounds, and then what we're actually going to do is drag the negative bounds into our value x component, and then the positive bounds in our value y component. So now we can come in here, and this will be pretty quick. Uniform vec2 u grid res uniform float u aspect and u grid res and u bounds are both vec2, and then u aspect is a float. So we can say vec4 uv equals our input, which we're getting from over here. Now we need to convert from 0, really it's like this, 0, 1 to -1. Oh, actually, we don't need to do that. All we really need to do is okay, I actually did this a little bit wrong. So this u bounds should stay our bounds x, and then this bounds y should be parent.grid.par.aspects. Whoops. Where is it? There it is. Okay, so I want to give my tile grid this parent shortcut grid, and that will let me reference it using the parent shortcut here. And I should actually do dot grid here and here and here and here. Now we have an error, that's that color is not identified. Okay. All right, so now we have a x and y value and a z value. Okay, so now that this is aspect corrected to be x and y bounds for our aspect ratio, now we can convert from 0, 1 to -1, 1. And that is UV equals UV times 2.0 minus vec2 of 1. And then UV times equals ubounds dot xy. And this is to remap from -1, 1 to world space bounds, just like that. And there was a little vec2, vec4 conversion. And so just make sure that I specify that I just want the first two components of each of our vectors. And now we don't have that error anymore. And if we open this viewer and click N to see normalized, we can see that we have X values from about minus 97 to 97 and about minus 54 to 54 for Y values. So now what I'm going to do is just create a little null, call it position. Then I'm going to create a constant, add a null. I'm going to call this null scale. I'm going to add a parameter. I'm going to call it tile size. Make it possible to go up to 100. Default it to 50. And then drag and drop this tile size onto the color. Make sure it's a 32-bit float. And we can verify that here. Cool. Although we can make it a 32-bit float mono. Okay, so now let's see the magic. Go back to our instancing. In this case, we're going to use pose as our translate op, R, G, and B. And then we're going to use scale and just use the R value for all of our scaling. And then again, this dot slash indicates that we need to go inside the component to look. Now we're not seeing anything because we need to have this constant be the same resolution. And then boom, look at that. We are getting something, something in somewhere. Okay, so let me make, aha, and this is what I mentioned with the manual. So now we really need to scale out our camera. So I'm going to scale it way out to like 260. And I happen to know that 260 works really well with the bounds of 100 to get kind of this centered view right here. You could, looks like at about 240 or so, maybe 240 exactly, and then we can scale up our tiles a little bit. Is like a nice snug fit. I like something a little bit smaller so that there's some margin. The reason for that is you saw at the beginning I had the frame and the dust kind of bordering. That's completely optional. But anyway, 250, 260, 240. Just choose some value that works well. And so now we can see all of our nicely arranged tiles. We can also see that as we are dragging all of these tiles, as we are changing our target grid res, our tile spacing just updates dynamically, which is great. And then we can change our tile size. And the cool thing about this is that it goes down to a very small number of tiles, just, 4, or we can extend it up to, almost 10,000 tiles here. So I'm going to maybe stay somewhere up here on the higher end, around like 90 tiles, and then maybe something like this. Well, I'll make it bigger for now. Okay, so we have our grid now nicely arranged. So that's great. It's looking good, but I mean, it's not really looking good. It's looking nicely arranged, but kind of funky because, again, our texture mapping is all wrong. So now we have to do our texture mapping. So we'll call this instance data. call this texturing. So again, what we're looking to do here is to calculate for each of these tiles specifically what chunk of our base texture that tile is kind of like responsible for rendering. So let's see if this works. So if I make it all square, 1,000 by 1,000, and then we go open up these parameters, and I make it a pretty small grid with huge tiles. So again, this is just copying the four textures, but I think it makes it intuitively a little bit more clear kind of what we're trying to accomplish. Ideally, what we want here is for this to be the lower left half, or the lower left quadrant, upper left quadrant, upper right quadrant, lower left quadrant. And so, but we want that to scale, right? We don't want to map it out individually, which we could do. For 4, it wouldn't be that hard, but it gets pretty hard when you have 10,000. So we're going to use this texture chord op field in our geometry instancing parameters. And what this lets us do is actually give each instance a UV coordinate that represents the bottom corner, essentially, of the texture where that tile is going to begin looking up. So right now, every single instance is getting 0, 0 for U and V, and that means that it's starting its lookup at 0 for U and 0 for V. Here, maybe we can give ourselves a little something. So I'm going to copy and paste this UV. And I'm going to then put a constant and make the constant set resolution only. And I'm going to drop a null and call it text ID. Actually, maybe text chords is better. Now we'll use text chords R and G to look up our texture coordinates for each instance. Now, this is a little bit funky, and that's because we need to do some scaling on our texture here. So this constant is set to 1, 1. If I set it to 0, 0, then it means that we're looking at just this bottom pixel of color, which I guess is actually interpolating. Okay, so because now interpolation is off, we're looking at the bottom pixel. The key thing that I always forget to do is to change this texture mode to transform. So from replace to transform. So at replace, it's saying replace all of the texturing that we're doing with just the lookup from RG. And that is giving us a single pixel value for all of our quads because there's only one pixel value for each pixel. But if we change it to transform, then what it's going to do is instead shift the texture and use these RG or UV coordinates as the starting lookup. So we can see now that when I'm shifting my RG coordinates here by using this constant, it is actually changing the mapping of the texture. And if I reset this to 1, 1, that means that our texture lookup starts in the corner. And then if I move it down to 0, then it starts in the other corner. So what we would really like to do is to have each of our tiles have a texture ID lookup that starts um, a fraction of the way across the image. And that fraction is based on the tile, the row and column that the tile's in. We want this texture to start halfway, we want this tile's texture to start halfway over and the whole way down, for example. Luckily, we already have a really handy way to do that, and that is using our UV. So if I just use our UV and give us more grid, okay, so like, we're seeing something happening, but it's not really looking quite right. And the reason, well, there's two reasons for that. One is because we are still looking up the entire texture. We're just offsetting where we start. And so what that means is I am still looking at the entire base image when I'm texturing just this quad. I don't really want to do that though. I really just want to look at the upper left chunk of the image, or sorry, the upper right chunk here of the image. So I want to offset my lookup using the UV to change, how far into the image my lookup starts. And then I want to actually use a texture SOP to scale how far I'm looking up from that offset starting point. An easy way to do that is just going to be to take this grid scale and take the reciprocal of it. So now we see that at least in some cases, this is starting to look a little bit better. We're looking at only going part of the way, in this case, halfway across our texture with each instance. So you can think of this again as kind of the percentage of the entire overall texture that each instance is going to be displaying. It's still looking a little funny though, and that is because we need to offset our lookup. We want to make sure that we are looking up in the center of the pixel and not the corner of the pixel. And so what I'm going to do that is simply take color.rg and I'm going to subtract equals and then here we can do vec2 of a 1 and divide it by utd2d infos 0.res.xyzw. So zw is the resolution and xy is 1 over the resolution. So you can either do times res xy or divided by this ZW. And then we want to do 0.5 so that we can move just half a pixel. So again, and now we see that our mapping is indeed correct and is exactly how we want it. If I give us 4 tiles now and drop down the tile size, 4 rows of tiles rather, we can see that indeed we are kind of perfectly making our mapped tiles, and this is all working just as it should. The magic there was, again, just using this 0.5 to adjust our lookup from the corner of a pixel to the center of a pixel. Or rather, I guess, from the center of a pixel to the corner of the pixel. And this xy is the same thing as 1 over the resolution. So I'll make a note of that. utd2d infos 0.res.xy equals 1 over res. note. And so now we have a perfectly mapped mosaic grid tile system. I'll make my resolution back to 1920 by 1280. We'll drop down the size of our tiles and get some more tiles. Nice. Okay, so now I'll go back to my 22 and target size 90. And so you can start to see if you just move this tile size and mess with it, the visual effect can be quite different, but it's pretty cool. And so that is a pretty good stopping place, I think, for this part of the project. So to reiterate, what we've done is take any number of scenes. This will work perfectly well with any scene, so we can just drag and drop these to replace them. Any scene. We have rendered it on a virtual canvas that is created of these tiles, and the tiles are all mapped really nicely so that we have a perfectly mapped, cohesive, full image, but then can also permute and distort to give ourselves a lot of options when it comes to designing installations. So, like I said, that's it for this iteration. Thank you guys a lot for all of your support. Thank you for sticking with me. I know I've been not putting out quite as much content recently. I've been busy doing a ton of projects, a couple permanent installations, a couple events, and an exhibition for Art Basel. So there's been a lot of things that have been going great. But I'm looking forward over the winter to really diving in and getting some more content out there for all of my Patreon supporters. So thank you again. And in part 2, we're going to take a look at how to start disturbing this canvas, adding some turbulence, and then looking at how to start adding some of the more aesthetic pieces, such as the background, the framing, and other pieces of that sort. So thank you very much, and I will see you then.